welcome to almost the last two talks. First of all, to thank the organization of the meeting and the very interesting talks that were before. I'm sure that the next one will be one of the next two will be very interesting. So my talk is assessing the reliability of drug property predictions. I'm Carrio and I'm working in the pharmacoinformatics group where I will defend my PhD thesis very soon. And my project, or my thesis, was mainly funded by the eTOX project, and that's why I will use the eTOX presentation template. Okay, the idea of my talk is to avoid situations like that, but in drug prediction, not in weather prediction. So, okay, the main objective, it will be a very fast presentation. So, the objectives of our project was to make QCR predictions in toxicology easier to use for decision making. And we understand easier to use or usefulness in this context for making prediction more reliable. So it's difficult to make QCR that they perform better, so they must be more reliable. Okay. And reliability has appeared many times in this conference, and just to frame it, so if we want to predict some unseen compound for a property, we might look for QCR models and select among all them the best one. And this, we get all this information from the validation assessment data, which has the best error square, Q-square is dead, and so on. Sensitivity. Okay, once we have our model selected, we have to evaluate that the model is suitable for our compound. And this information is hidden in the applicability domain assessment. It tells us if we are inside or outside. And once we have the model, or query compound, we can make a prediction. And here the question is, how reliable is our prediction? And talking about reliability, there are two assumptions that are very important for us. The first one is that you will not be able to make predictions that are more reliable than the ones that you get in the training set. So in the training set sets a baseline, and from here, as when you go away from the training set, you will get predictions that are less and less reliable. And what I said in the slide before, the information for setting the baseline is the information that you get from the validation assessment. And how far you are, it's an information that you might get from the applicability domain assessment. So for starting our work, we set up some principles that should guide us. And very briefly, it was very important to compare a query compound to the training set. But here, comparing is quite difficult because there are many ways of comparing. And when doing predictions, there are several ways a compound can be poorly predicted. And that leads us to many ways of comparing or assessing this. So we decided that comprehensive similarity measures, so measures that are easier to describe and to understand, are preferable than accurate similarity measures. And also for one principle, it was that we should avoid to set arbitrary cutoffs, in the sense that the data itself should tell us which cutoffs to use. Okay. So we wanted to compare, and we decided to go for three areas. The first one was choosing for differences in the molecular descriptor space. And here we decided to pick up two rules, very simple ones. So to get the distance from our query compound to the centroid of the data in the training set, and getting the distance from our query compound to the closest compound. And here it was to mention that we are not using directly the molecular descriptor space, rather the score space provided by a BLS model. And this had two benefits. One, that it was activity biased. One, it was activity biased, and the other, that we were able to control all the variation that it was explained by our model. What we did in the molecular descriptor space, we did it very similarly in the activity space. So for the query compound, we got a prediction, and we set up the differences between the prediction and the average value, and the average value of the actual values, and the value of the closest compound in the molecular descriptor space that it's painted in. It's not. And in the third space that we looked, it was in the model space, and we looked for, okay, my query compound is in somewhere in this space. How performs our model in that area? And we decided to go to get 5% of the closest compounds in the training set, and calculating the standard deviation error of the predictions. And also we take since we were using these PLS models, we were able to use how much of this query compound is not inside our model through the eTOX. Okay, so we had a set of rules, and that we were able to calculate for any query compound. And we decided that a rule was broken if compared with the values obtained from the training set was above the 95%. Okay, this was about a bit technical, but the idea is that we end up with categorizing all our predictions according to the number of broken rules that we have. We performed the validation with different datasets, regressions, and molecular descriptors, but we used an extreme situation for making the train and the speed set to force more realistic approaches in fact QCR applications, which is consisted mainly in what you see in the plot, so collecting more or less in a fuzzy cluster all the compounds in the training set and a lot of test set compounds around. So that was the validation. We got the query compounds, we send it to the QCR model, so we get the predictions and category. And what we observed it was that, what is shown in the box plot, that when we increased the categories, we were seeing that the predictions were worse. And that was an example, but we saw the trend in all the combinations from molecular descriptors and all the data sets that we checked and all the regression models. So the trend was more or less stronger, but there was always a trend. Just a comment to confidence intervals. So if the error of the prediction will follow a normal distribution, we will have these confidence intervals for the 95% that will be plus minus the standard deviation error prediction multiplied by 1 by 2. And we wanted to relate all categories with these confidence intervals. And what we did was to see how they relate, if the prediction were failing inside or outside. Okay. And that is what's shown here, and again, that was what we see in all the combination. But when we increased the number of broken rules, we saw that we were more away from the confidence interval. And we tried to set up some approximate confidence intervals that were related or categories to some widening of these confidence intervals. And we proposed a very simplistic approach, that if there were lower categories, we will use the confidence intervals per se, otherwise we are multiplying by integer factors. And this allowed us to codify these time categories to some reliability measures in this semaphore line. So in green, yellow, and red. And the idea here, it was a bit reflecting what users in the eTOX systems will need. That they are querying several models and they need to have some feedback on the reliability of the predictions in a very easy to understand way. And this our framework it crashed everything in this semaphore that I think is quite easy to understand. And the users that mostly were toxicologists were very happy with this approach when comparing different prediction per second. And again, we saw this in different in all our cases. Okay, in order to make easier to use all these nice applications, we have two deployments now. One is an Air package that is accessible in GitHub in ADAN, which is mainly consists of two functions, one for training tool, and the other one is for just querying and retrieving two things. One is this category, and the second one is the confidence interval, where the prediction should be. And the second one is this, with the eTOX projects they are building, so these eTOX virtual machines that contains models packaged with everything, and in particular it contains the eTOX lab, which is a nice way to encapsulate and deploy and a platform for building models in the context of eTOX. And I included here the reference for more details that you probably will be asking after this very fast presentation. Okay, I will skip this example and just go into the conclusions. So the strategy incorporates diverse sources of prediction errors. That it's very key because QSARs hide many errors. Then the strategy provides a robust approximate estimator of the prediction errors, allowing us in different situations to deal with this uncertainty. The method works unsupervised, and we think that QSAR predictions are easier to use, and in the sense that they are more reliable and we can trust them a bit more or less. I want to acknowledge Manuel Pastor, that was behind some of the ideas in this discussion here, and the rest of the people that provided the data and us, and also eTOX funding, and you. Thank you for your attention.